Welcome to another episode of our Azure Networking series. Today, we're focusing on a crucial topic, DNS resolution issues in Azure. DNS or domain name system is essential for translating domain names into IP addresses, enabling communication across networks. In Azure, reliable DNS resolution is vital for your applications and services to function smoothly. In this episode, we'll cover the basics of DNS in Azure, common symptoms of DNS issues, and practical steps to troubleshoot and resolve these problems. Whether you are managing a simple web app or a complex cloud infrastructure, understanding DNS troubleshooting is key to maintaining a reliable Azure environment. Let's dive in and equip you with the knowledge to handle DNS resolution issues efficiently. First, let's check out the environment architecture we chose for our session. So basically, we have two paired VNets. The first one is dedicated to the VM and Bastion. And in this second one, we made a virtual network integration for the web app, where the public access is disabled. To open private access, we need to create a private endpoint. So let's create it now. Let's name it, choose the subscription, the virtual network. Concerning the subnets, it must be dedicated only for the private endpoint, as the case of several other services. Now, the portal requests if you want to integrate to the web app with a private DNS zone, and that's what we actually want. If we check it, there is two cases. One, we already have one named privatelink.azurewebsites.net in the resource group of the selected subnet. Then the private endpoint will be integrated with it. And if it doesn't exist, it will be created automatically. About the naming, Azure dedicated specified names of private DNS zones to each service. You can find the list of these names on Microsoft documentation. And here you can find the name chosen for the web apps. After the creation of the private endpoint, our infrastructure is all set. The virtual machine must be able to access the web app. Let's check it out. We access the VM through Bastion, open a navigator and write the FQDN, but the access is denied. So what is the problem? We know the public access is disabled, but we set our infrastructure to enable private access. Let's check if our traffic is going private or not by using the command nslookup. Ouch, we got the public IP. So when the traffic goes up to the virtual network and asks for the IP address associated, it gets the public one, which means it doesn't use our private DNS zone. Let's check first the virtual network DNS server. It's set to Azure, the default choice. Azure uses generally its own public DNS, unless we link a private one. Then it will privilege the private one. So maybe the problem is that our virtual network is not linked to the private DNS we created. Let's go check. This is our private DNS. Click on Settings, VNet Links, and there we go. The only virtual network linked is the web apps one. So we need necessarily to link it to the VM's VNet. We assign the links name, choose the subscription and the VNet one. Here we go. Let's try now the nslookup command. Excellent. We got the private one this time. And subsequently, we will have access to our web app. You can see it's just empty as we didn't deploy anything in it. Now, let's move on to the second troubleshooting scenario. We made a small change in the configuration that could easily happen mistakenly in real-life scenarios. As a consequence, we no longer can reach the web app. What could be the problem? Let's follow the same logic the traffic flows from the virtual machine to the virtual network, which uses Azure's default DNS. This DNS is linked to the virtual network. Now, does the DNS have the record of our web app? Normally, it would be created automatically when we set up our private endpoint and linked it with the private DNS zone. However, it appears someone accidentally deleted it. Wink wink. DNS relies on a record table where each line maps a domain name to an IP address. We can clearly see that our FQDN doesn't exist in this table, so we need to add it. We enter the web app's name and set the type to address record. The time to leave refers to how long a packet stays before being discarded, so we'll leave it as it is. We assign the private IP address in here. Now, let's recheck the connectivity. By using NSLOOKUP, we retrieved the private IP address, so we can successfully reach the web app. That would be everything for today. Thanks for watching. Don't forget to like, comment, and subscribe for more. Goodbye.